We have been exploring different types of factoring, which is basically the opposite of expanding. So first of all, we looked at finding greatest common factors to break polynomials into smaller pieces. If we can't find a greatest common factor, our next step is to look to see if we can find common factors within pieces of a polynomial and use the factoring by grouping strategy to factor the polynomial. And when that didn't work, we started to look at the number of terms that a polynomial has for clues on strategies that we can use to factor the polynomials. So in our last lesson, we looked at type 1 trinomials. So trinomials in general, when we're using this type of factoring, are in the form ax squared plus bx plus c, where a is equal to 1. And because we don't usually write 1, the a is like wouldn't actually show up because it's like having an invisible 1 there. So for example, if I have x squared plus 7x plus 12, that would be an example of a trinomial. It has an a value of 1. We don't see it there. And we can factor this using our man method, or the type 1 trinomial strategy that we talked about last time. So what we want to look at today are type 2 trinomials. And type 2 trinomials follow this very similar pattern. So ax squared plus bx plus c. But this time, the polynomial does not have an a value of 1. So for example, if I look at 3x squared plus 7x plus 12, in this case, the a value would be 3. So we would call this a type 2 trinomial. So type 2 trinomials are a little bit more, there's a little bit more of a process to being able to factor them, and that's what I'm going to show you right now. And before we actually get into that process, I do want to just do a quick review with you of how to expand some binomials using the FOIL method in order to get a polynomial, in this specific case, a trinomial. So for example, if I started with two binomials, so 2x plus 3 times x plus 5, if I wanted to expand this out, that means I'm going to multiply everything by everything to get rid of the brackets. So 2x squared plus 10x plus 3x plus 15 then condenses down into be 2x squared plus 13x plus 15. And sure enough, this binomial, when we FOIL it out, actually creates a type 2 trinomial. Okay, so we're going to keep that in mind. I just wanted to show you kind of another way of thinking about this expanding process, because this is something that we can use when we're working in the opposite direction when we want to start factoring it. So another way to think of this is I can say, okay, I'm going to take this 2x and I'm going to multiply both the x and the plus 5 by that 2x. So the 2x is being multiplied by x plus 5. And then I'm going to take the 3 and I'm going to multiply it by x and I'm going to multiply it by 5. And so here I have 3x plus 5. So I can think of this polynomial here as the expansion of 2x, x plus 5, plus 3, x plus 5. And hopefully this looks familiar to you, because this is one of the intermediate steps that we used when we were doing the slice and dice method. Remember, our goal was always to have kind of two pieces with the same common factor in the middle, and then we were able to pull out that common factor when we were factoring it. So again, we're going the other direction, we're expanding. So then if I were to expand it out, I would still end up with my 2x squared plus 13x plus 15. Okay, so I just wanted to kind of put this into your head here. We end up with the same answers, just a slightly different way of thinking about it. But this middle part here, the 2x times x plus 5 and the 3 times x plus 5, is an intermediate step that we're actually going to try to recreate when we go in the opposite direction and when we're factoring. Okay, so this is how it's going to work. We are going to factor the expression 2x squared plus 13x plus 15. So we're going in the other direction this time. I'm giving you the polynomial. We want to rewrite this in factored form so that we've got the brackets in there and pieces are being multiplied together. So here's the trick. We're still going to use the man as our acronym here. We're still going to find two numbers that multiply to something and add to something. But this time, instead of just multiplying to our c value, we're going to multiply by the number we get when we take our 2 times our 15. So 2 times 15, or a times our c, is equal to 30. We still want those two numbers to add to our middle term. So in this case, we want them to add to 13. So we need to figure out two numbers that are going to multiply to 30 and add to 13. So some of you may be able to just do that quickly in your head, and that's great. If you don't see the result right away, or the answer we're looking for right away, you can think about what are the factors of 30. So when I break down 30, I can do 1 times 30, 2 times 15, 3 times 10, 5 times 6. And when I look at all the factors of 30, I see that 3 and 10 multiply to give us 30, but they also add to give us our 13. So 3 and 10 look like a good option for us to use in this situation, okay? So remembering up here, we want it to look like this so that we can go in the opposite direction. We want to be able to slice and dice this factor by grouping. So what we're going to do is we're going to turn this trinomial into a polynomial with 4 terms so that we can slice and dice it. And we're going to do that not by changing its value in any way, but by changing the way it looks. So instead of writing 13x, we're going to take these two numbers and we're going to break that 13 into 10x plus 3x. I could have also written 3x plus 10x. The order is not important there. So the idea is that these two polynomials are equivalent. My 2x squared stays the same. My c value of 15 stays the same. And I've just broken up that middle term to be 10x plus 3x, which is still equivalent to 13x. I haven't changed its value in any way. However, because I've changed the way it looks, I am now in a situation where I can take this type 2 trinomial, I've turned it into a polynomial with 4 terms, and I can see now, I can test it out to see if I can slice and dice it, okay? So I'm going to cut it down the middle, I'm going to slice it down the middle here, and I'm going to focus on each side independently. So when I look at 2x squared plus 10x, I'm going to find the greatest common factor here, which is 2x. That leaves me with x plus 5 left over. And on the right side, 3x plus 15, the greatest common factor is 3, so I'm going to factor it as 3. That leaves me with x plus 5 as my other factor. And this works out perfectly because now I see an x plus 5 here, I see an x plus 5 here. I'm going to common factor that out of both terms, and then I've got 2x plus 3 left over. Okay, so when I take my 2x squared plus 13x plus 15, and I break it down, I decompose it, I slice and dice it, I end up being able to factor it by grouping in the middle to end up with x plus 5 times 2x plus 3, which is exactly what we started with at the beginning. Okay, so this page here, I'm just going to zoom out here. This page here shows how I can take an expression 2x plus 3, x plus 5, and expand it to get my 2x squared plus 13x plus 15. And then I can go in the other direction using this strategy of, again, finding two numbers that multiply and add, but this time using those two numbers to break the polynomial up into a polynomial with 4 terms, slice and dice it to get our factored form. So I'm going to go through one more example here of how to do this so that you can see another one done for you. So this time we have 4x squared plus 20x plus 9. This is a type 2 trinomial because my a value is 4, so I know I just can't do a simple man. I'm going to do a mega man. That's what I call this one so that I can tell the difference between a type 1 and type 2 trinomial. So for this one here, I'm going to look to find two numbers that multiply to 4 times 9, which is 36, and add to my middle number, my b, which is 20. So when I think about the factors of 36, I get 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And my 2 and 18 seems to work because 2 times 18 is 36 and 2 plus 18 is 20. So I'm going to take this middle term 20x and I'm going to divide it up to be 2x plus 18x. I haven't changed its value in any way, but I have changed it into a polynomial with 4 terms that I can now slice and dice. So I'm going to cut it down the middle. I've left my 4x squared and my 9 the same, and now I'm going to factor the left side and the right side with the goal of trying to get the same bracket on each side so that I can common factor out that bracket. So on this side here, my greatest common factor is 2x. That leaves me with 2x plus 1. On the right side, I have my greatest common factor is 9, which leaves me with 2x plus 1 in the bracket. And now, goal accomplished, I have my 2x plus 1 in both of those brackets, so I can pull out that 2x plus 1, and I've got my 2x plus 9 left over. And this is our fully factored form. And one of the things that's probably a good habit to get into is to always look at your final factors just to make sure there's no greatest common factors or anything that you missed. So when I look at 2x plus 1, that's broken down as far as it can go. There's nothing else that I can pull out of it. And that's the same with 2x plus 9. There's no greatest common factor or anything else I can do to factor that further. So we call this a fully factored form of 4x squared plus 20x plus 9. I do want to show you kind of on that idea of fully factoring, just one example where we can actually factor it to break it down and make things easier. So if I give you 2x squared plus 6x minus 36, that is a type 2 trinomial because the a value is 2. However, if we look carefully, 2, 6, and 36 are all factors of 2. So I can pull out the greatest common factor of 2, and when I do that, I'm left with x squared plus 6x minus 18. So by pulling out that greatest common factor of 2, not only have I broken down the numbers and made them smaller to work with, but I've actually turned this into a type 1 trinomial, which is easier to solve because then I can just use the first man method that we used. So now I'm looking for two numbers that multiply to negative 18 and add to 3. So I think about all those factors of 18, and I notice that 3 and 6, if I have positive 6 times negative 3, that equals negative 18. And if I have positive 6 minus 3, that equals 3. So 6 and negative 3 work well for that. So I'm going to put them into my brackets. And this new part, my x squared plus 3x minus 18 factors to be x plus 6 times x minus 3. And my fully factored form now is 2 times x plus 6 times x plus 3. So there are some cases where you can make your life easier by recognizing greatest common factors right off the bat, turning your type 2 trinomial into a type 1. And then you don't have to worry about doing that middle process of decomposition and factoring by grouping to get to where you want to go. Okay, so hopefully these examples will help you as you work on some of your type 2 trinomial problems.